Children, this is Shivalsis speaking. Children, we are going to deal with exercise 14.2 as we have discussed about few questions of exercise 14.2. So now here today we will be talking about some questions of that particular exercise. Question number 7. L plus m whole square minus 4lm. L plus m whole square minus 4lm. Then the next one I have chosen to explain, that is question number 8. A to the power 4 plus 2 a square b square plus b to the power 4. Then I'll be switching over to the next question. These are of question number 2. 4p square minus 9q square. Then question number 2, that is 63a square minus 112b square. And the next one is L plus m whole square minus L minus m whole square. Okay, children. So let's go for the first question. That is question number 7 of question number 1. In the previous video, I have already explained about the identity of a plus b whole square and a minus b whole square. So here in this particular video, we will be discussing about L plus m whole square minus 4lm. How to factorize this, excuse me, how to factorize this number or other expression, that is L plus m whole square minus 4lm. Let us have a look. So here, L plus m whole square minus 4lm. Children, so what we can see over here, this is a plus b whole square. L plus m whole square means we can break this, we can factorize it using a plus b whole square format. So let us go ahead. A plus b whole square means a square plus 2ab plus b square. Actually, in the place of a plus b whole square, it's written L plus m whole square. That's why we have replaced a plus b whole square using L plus m whole square. So that is what we are going to write now over here. This is L square plus 2lm plus m square. And the next one is minus 4lm. It was as it is. So L square plus 2lm plus m square minus 4lm. So children, here we can see that if I write L square as it is, here is 2lm plus 2lm and there is minus 4lm. They can be calculated. 2lm and minus 4lm can be calculated. So this is what I'm going to do right now. Plus 2lm minus 4lm is minus 2lm. Plus 2lm minus 4lm results minus 2lm plus m square. Plus m square. So now here, this a square minus 2ab plus b square. Now this particular part is giving one more identity, that is of a minus b whole square. So here just now I got L square minus 2lm plus m square. That can be factorized or that can be removed using a minus b whole square. Children, don't get confused if I'm uttering the word a minus b whole square and writing L minus m whole square. That there is no difference at all. Actually, a plus b whole square or a minus b whole square, it's just a common identity. In the place of a, we can have a, b, c, d, a to z, any alphabet. In the place of b, we can use any alphabet. So that doesn't make any sense. That there is no difference at all. So here, this is what I'm going to write now. L square minus 2lm plus m square will be replaced by L minus m whole square, because we know the identity. The identity is a minus b whole square is equal to a square minus 2ab plus b square. Children, those who have missed out my class, previous explanation, they can relate these things. Again, a plus b whole square is equal to a square plus 2ab plus b square. These are two identities which we are using for factorization. So children, here is the question. It was L plus m whole square minus 4lm. So we have factorized it in this way. We have replaced, we have calculated. So plus 2lm minus 4lm is resulting minus 2lm. And L square minus 2lm plus m square results L minus m whole square. So I believe it's quite understandable and it was really very easy to solve. Children, let us talk about the next question. The next question is a to the power 4 plus 2 a square b square plus b to the power 4. You might be thinking, sir, we know the identity, that is a square plus 2ab plus b square, but here it's written a to the power 4 plus then 2a square b square plus b to the power 4. No difference at all. We will use one trick. We'll be using a trick to factorize this particular format. We will be using a trick to factorize this particular format. What is this? Let us check it out. A to the power 4. A to the power 4, can we write it as a square on square? Yes or no? Yes, we can. If I express a to the power 4 in the form of a square on square, I'll be getting a to the power 4. The square on square results a to the power 4 plus 2a square b square. I'll write it afterwards. B to the power 4 means b square on square. Square on square results b to the power 4. That is b to the power 4. Square and square is b to the power 4. Because 2 2s are 4. Because we have already learned these concepts while we have done the chapter exponents and power. In that particular chapter, I have already explained that the power on power, if power remains on another power, they get multiplied. So square on square results b to the power 4. So here, children, now the question is that how will we express the middle portion to AB? Actually here, A means A square. A square means A. Again, B means B square. B square means B. Don't consider it square on square. No. Actually here, A means A square. B means B square only. So according to the formula, I have to write 2AB over here. So I'll write 2. A matlab A square, B matlab B square. So it's actually 2AB, children. Because according to the identity, it's supposed to be A square plus 2AB plus B square. But actually as we had got A to the power 4 and b to the power 4, so a to the power 4 I have expressed in the form of square and square, and b to the power 4 I have expressed in the form of square and square. Right? So that's why I'm getting the answer, I'm getting the format in this particular way. So it's square and square, so it's a to the power 4, b square and square is b to the power 4, 2ab matlab 2 into a square into b square. Right? So it's actually 2AB. It's not 2a square b square. It's 2AB. So children, this is an identity of what? A plus b whole square. So as now I have said that it's a square plus 2ab plus b square. The identity is a plus b whole square. It's an identity of a plus b whole square. A matlab a square, b matlab b square, and whole square. It's a plus b whole square. This is how we have to write this format, a plus b whole square. I believe it's understandable. The next one is 4p square minus 9q square. 4p square minus 9q square. So children, this is another part of the factorization. This was some common concept of a plus b whole square and a minus b whole square. Right now we are going to deal with one more new identity. The identity is a square minus b square equal to a plus b into a minus b. It's one more identity, children. A square minus b square is equal to a plus b into a minus b. A square minus b square is equal to a plus b into a minus b. So here what are we going to do, children? We are going to factorize this in this particular form, a square minus b square. Now you might be thinking, sir, how did you understand that we have to factorize it using a square minus b square? Actually it's written 4p square, so I have an idea. Somehow I can make it as a square. Or it's written minus 9q square. Somewhere I have got an idea that I can make it as b square. So how will I make? That's my technique. Let us check it out. 4p square, I want to write it as 2p whole square. Why? Because this square is on p as well as on 4. So I want to just make this 4p square in a square format using this square on 2 and p both. So while I have written this square on 2 and P, it means that this square is applied on 2 as well as on P. So 2 getting this square is becoming 4 and P is getting this square becoming P square. So it's 2P whole square matlab it's actually A square. Now the next one is 9Q square. So 9Q square can be factorized, can be written in form of 3Q whole square. How come? See, this square is on 3 as well as on Q. So 3 square matlab 9, Q square matlab Q square. So it's actually turning it into A square minus B square format. It's actually turning it into A square minus B square format. So this is what I'm going to do right now. A square minus B square is actually A plus B into A minus B. A plus B means 2P plus 3Q. A means 2P, B means 3Q. Again, A minus B matlab 2P minus 3Q, A minus B. This is what my answer is all about. I cannot factorize it further. If I break it further, I'll get the question in written. So there is no use of factorizing this particular part once again. So I believe, children, it's understandable. Now, the next question is 63A square minus 112B square. Let us check it out how to do this. 63A square and 112B square. Children, I cannot make a square of 63. I cannot have the a root over of 63. I cannot have I can't make 112 over here. I cannot bring it. So what I have to do, I have to take some number common. I'll be taking some number common. Let's check what it goes actually. What can be taken as common? If I take 7 away from 63A square, it's becoming 9A square, because 7 into 9 is 63, A square, A square. I'll take 7 away from 63A square minus. If I take away 7 from 112, what remains? No, it's not coming. So what can we take? Any bigger number? Any bigger number can be taken. It's 63A square minus 112B square. Yes, 7 only. 7 ones are 7. 4. 6 sevens are 42. Yes, 16B square. It remains 16B square. If I take 7 away from 63A square, it remains 9A square. And if I take 7 away from there, it remains 16B square. Now I can factorize this. I'll write 7. 9A square, I'll express it in form of 3A whole square. And 16B square, I'll just express it in form of 4B whole square. No problem. Alright. Now let this 7 be as it is. Now A square minus B square identity can be utilized over here. Formula is A plus B into A minus B. That's all. This is what my answer all about. So children, this is how we will be dealing with these questions. Let me show you the entire board. This is the entire board work. If you have got any doubts or confusions, I can take a snap of this and I can upload in the WhatsApp group. No problem in that. So children, the very first thing that what I'm doing, I'm just taking a move of the entire video once. Entire board once. You can pause the video and you can write the things written on the board. Till then, thank you so much, children. Thanks a lot. Thank you so much.